Hello children, today we will be starting a new chapter, that is refraction of light through a lens. Especially we will be discussing terms related to the lens. First we will discuss what actually lens and the types of lenses, then we will discuss the terms related to the lens. So dear children, first let us see what actually lens is. Children, before going to understand the lens, let us recall what actually prism. Dear children, there is a similarity between prism and lens. Of course, there is a difference also. Let us recall, dear children, what is a prism? So, prism is a transparent refracting medium, but which is consisting of what, dear children? Plane surfaces, which already we had discussed in the previous classes. But when come to the lens, dear children, lens also transparent refracting medium, but consisting of curved or spherical surfaces. It is a very important thing is that here it is consisting of, dear children, curved surfaces or spherical. You can say that it is a spherical surfaces. Spherical surface. So that makes the difference between. So whereas prism means plane surfaces. Prism is consisting of plane surfaces, whereas lens is consisting of curved or spherical surfaces. So, what is a lens is? A transparent refracting medium which is consisting of a spherical or curved surfaces is called lens. Of course, Richard, sometimes it may be consisting of only one curved surface, another might be a plane surface. And don't forget that, children, a plane surface also a part of a spherical surface only. Clear? Fine. Now we will discuss the types of lenses. There first we will discuss convex lens, then we will discuss about a concave lens. So first, dear children, let us discuss about convex lens. What actually convex lens is and the types we will see. Children, so whenever a convex lens is given, actually we are dealing with the only thin lenses. So by seeing from far, actually we cannot recognize unless and until we touch it. So children, look at here. So convex lens appearance will be like this. Means in middle it is thick, very important, and at periphery, at edges it is thin. Children, it's very important. So convex lens, its middle part is a thicker, whereas at the edges it is a thinner. This is what actually convex lens is. Now let us see what actually concave lens also, so that we will get a clarity between convex lens and a concave lens. So here let me talk about here concave lens. So how does concave lens look? Means with a physical touch only we can say this. Okay, children, fine. So here is concave lens is like this. Now look at here, children. Concave lens, middle it is thin, whereas at edge it is thick. Edge it is thick. So children, this is a basic difference between convex lens and a concave lens. Children, convex lens is thicker at middle, thinner at the edges, whereas concave lens thinner at middle, at periphery it is a thicker. This is the main difference between the convex lens and the concave lens. Now we will see the types of lenses, dear children. So under convex lens and a concave lens. So mainly we are going to have three classifications under convex lens and as well as under concave lens. First we will see for a convex lens. The first one is, dear children, it is biconvex. Biconvex or equiconvex. Biconvex or equiconvex. So this is biconvex or equiconvex. So means this is consisting of two spherical surfaces, convex surfaces as usual, middle thicker, at the edge it is thin. But children, biconvex lens and equiconvex, again they are not same. So when we are discussing the terms related to the lenses, there I will tell you what actually the difference between biconvex lens and equiconvex lens. Just now you can remember like this one. Okay, fine. And the second one is that plano-convex lens. Plano-convex lens. Plano-convex lens. So children, the name itself will give the concept. Means one surface is a plane, so that another surface is a convex. So it seems to be like this. Plano and here is convex. Plano and a convex. And the third one is concave-convex lens. Concave-convex lens. Children, concave-convex lens, finally it acts like a convex lens only, very important, finite convex lens only. But how does it look like? Children, so concave. So first let us think, according to the name, let us think, then we will see what is the actual difference between concave convex lens and convexo concave lens, we will see. So children, so concave, so let us take a first concave surface, next convex. Okay, so it is like a crescent moon, right? Okay, it's like a concave convex lens. So there are the three types of convex lenses. Now we will see a concave lens region. The first one is, it is biconcave lens or equiconcave lens, biconcave or equiconcave lens, and it seems to be like this. So it is consisting of, the children, two concave surfaces, and whereas second one is plano concave lens, plano concave lens. So here one surface is a plane, so that another surface is a concave surface. So it plane, another surface is concave surface. Fine. Now come to the third one. Third one, it is convexo concave, convexo concave lens. So generally for this, how we made concave surface first, convex surface second. Now children, here, so convex, so first convex surface is coming, okay, convex surface, next concave surface, concave surface. Okay, so easy, right? But dear children, this is wrong. This is wrong. So this is not the way to write actually. Now look at here, dear children. Look at here. So as what I said, I said it is a concave convex lens. It is a convex concave lens. Kada. Let us see one important thing. In middle it is thick. Middle it is thick. At the edge it is thin. Right. But what about this? This also middle it is thick only. At the edge it is thin only. So nothing makes difference. Children, this is also concave convex lens only. So this is not the way to represent convex or concave lens. This is wrong. But generally few students, they will be following like this only. Convex, okay, first convex surface, concave, so concave surface. So it is a convex or concave. That is wrong. So this is not the way to represent convex or concave lens. Then how it should be? Look at here. So this is a surface, let us take here, fine, look at it. So this is going to be like this, somewhat it is going to be like this. Now look at here, now look at here. So it is in middle, it is thin, at the edges it is thick. So convex or concave lens behaves like a finally concave lens only, it behaves like a concave lens only. Children, here understanding first two is very easy, but there will be confusion with concave convex lens and convex concave lens. Children, try to understand. So whenever you are making either convex concave or concave convex, don't forget that. So if output is like a convex, means what here? You must get means middle thick, edge is thin only. But whereas convex or concave, middle it must be thin, at the edges, that at periphery, it should be thicker. Okay, children. So these are the types of lenses. Now we will discuss the terms related. So first let us take a here convex lens. Let us take here is a convex lens. First we will discuss the terms related to the convex lens and we will discuss its nature. Then we will discuss the terms related to the concave lens and we will discuss its nature. So in the sequence we will discuss. Children, here is, let us take one biconvex lens. Let us take it as a biconvex lens. The children, if you can take this one biconvex lens, so it has two refracting surfaces. First surface, let us say two spherical surfaces, and the children, each surface is a part of a sphere. Each surface is a part of a sphere. So this surface also like this. So these two spherical surfaces are a part of a two glass hollow spheres, and this glass hollow sphere has some center, right? Yes. Let us say it is a C1 and let us say it is a C2. C2. So why not it is a C1? Why not it is a C2? Children, the first, this is what we can say curved surface which is exposed to the light first. So we are taking the C1. And dear children, here C1, C2 is nothing makes different. Here, scientifically, there is no that much difference between C1 and C2. Okay. So dear children, here the C1 and the C2 only, we are going to call it as a C1 comma C2. We are going to call it as the center of curvatures. Very important, children. Center of curvatures. Center of curvatures. So how to define the center of curvatures? Children, the center of the glass hollow spheres in which the spherical surfaces, the sphere, the curvatures of the lens are apart. So that centers only we can call it the center of curvatures. And children, here, so there will be this geometric point. Children, it's very important. Geometric point. So what is this geometric point? The geometric point of the lens is called an optic center. Is called optic center. But dear children, scientifically, how can we define optic center? So if you want to understand the our term called optic center scientifically, then before that we need to understand one more point. What is that? Children, here just imagine one. Let us take one line, infinite line, and moreover it is an imaginary line only. So the imaginary line which is passing through the center of curvatures and optic center of the lens, let us name it as a XY. Let us name it as a XY. This XY only we can call it as a principal axis. We can call it as a principal axis. Children, an infinite and imaginary line which is passing through the center of curvatures and the optic center of the lens is called principal axis. Now come back to the point called optic center. Generally, optic center is what, children? The geometric center of the lens is optic center only. But scientifically, how can we define? Children, this is a point on the principal axis. Children, this is a point on the principal axis through which if any light ray is passing, will go undeviated. So why the light ray will go undeviated, that we will discuss in the next discussion. We will going to have that discussion only. Why light ray will go undeviated when it passes through the optic center? It is very important. So now let us discuss. Let us just recall once what actually optic center is. Children, the point on the principal axis through which any light ray passing after refraction will go undeviated. Okay, fine. Now dear children, here the distance between O and C1 is called R1, the first radius of curvature, whereas the distance between C2 and O is called R2, second radius of curvature. Children, this is very important to understand the difference between equiconvex lens and biconvex lens. So when we are discussing the classification of lens, there we wrote equiconvex lens and biconvex lens. But what makes the difference, children, it's very important. If R1 is equal to R2, R1 might be equal to R2, but it is not always. Sometimes R1 may not be equal to R2. Children, the convex lens in which R1 is equal to R2 are called equiconvex. Equiconvex. Whereas, if the radius of curvatures of the convex lens are not equal, then we can call it as a biconvex lens. Biconvex lens. Children, all equiconvex lenses are biconvex lenses only. But all biconvex lenses are not equiconvex lenses. Very important. So, children, equiconvex lens, the convex lens whose radius of curvatures are equal. Biconvex lens, the convex lens whose radius of curvatures are not equal. Whose radius of curvatures are not equal. So, children, so this is what actually equiconvex lens and a biconvex lens. Now we will discuss the nature of the convex lens. So how does it behave? So when parallel beam of light falls on it, how does it behave? It is very important. So here is nature of the convex lens. Convex lens. Children, after discussing these terms, especially we will discuss about a first focal point, second focal point, first focal plane, second focal plane. Okay, now first let us learn this. Children, let us take here is a convex lens. Convex lens. So, very thick convex lens which we have taken. Thick convex lens. So that it's very easy to understand what is going to happen when light incidents on the convex lens. Children, here Look at it, don't forget that here is air, here is a glass, again it is air only, again it is air only. So this is going to act like a rarer medium, and here is a denser medium, again it is a rarer medium. Look at it, children. So here is light is incidenting like this. Children, once again let us recall what happens when light moves from rarer to denser medium. Children, when light moves from rarer to denser medium, it slows down, speed decreases, due to which it bends towards the normal. Whereas when light moves from glass to air, it speeds up, due to which what will happen? Light moves away from the normal. So same concept which we are going to use here also. Children, now this is a point of incidence. Let us say this point of incidence, let us name it as some A or something. So let us say it is a point A. So here let us make a normal. So here we are making it as a normal. Children, we know that when a light is moving from air to glass, rare to denser medium, it has to bend towards the normal. So it will bend towards the normal. Okay, that is fine. It is bending towards the normal. Towards the normal. Children, let us say this is a point P. Again here what is happening? Light is moving from glass to air, that is a denser to rarer. Here also let us make one normal. Let us say it is a normal N1 and here is a normal N2, normal N2 children. Now as we know that when light moves from glass to air, denser to rarer, it moves away from the normal. So it moves away from the normal. So this is how actually the emergent ray which we are going to get after refraction. Fine. Now dear children, let us take one more light ray. Achha. So here is next one more light ray. Now similar thing is going to happen. Now here we no need to do anything. Of course, if you want, you can make again a normal. So here what happens? It gets deviated like this. Again what will happen? It is moving from denser to rarer. Again it gets deviated like this. So children, then finally what is happening here? Refracted light rays are meeting. So whenever light rays moves like passes through a lens, that is the convex lens, after refraction, dear children, the light rays are meeting at a point, means the light rays are converging. So here convex lens makes the refracted light rays to converge at a particular point. That's what, dear children, convex lens is also called as converging lens. It is also called as converging lens. So what is the nature of the convex lens, dear children? Converging action. It shows converging action. But dear children, in our discussion, we are not going to have thick lenses, right? So our discussion is only for thin lenses, which means what? For suppose, dear children, let us say T is the thickness of the lens. Children, we are going to have a discussion only for thin lenses, which means what? T tends to 0, which means what? T tends to means what? T is not 0, means this thickness is a very less, very less. So that's what it means. We will take like this. Look at here. So very thin we can take. Not this much also, not this much thickness also. So here what happens here? So directly, children, so whenever light is incidenting, directly we will take like this. That converging action we will take directly. Directly we can show that converging one means inside the children, as this thickness decreases, thickness decreases, obviously this length of the refracted ray also decreases, right? Length of the refracted ray is very small, so that we will neglect the refracted ray through this lens. So children, this is very general. In general, what happens when light ray passes through a convex lens is this, but our approximation means our discussion is only for thin lenses, so that we will neglect the refracted ray. That is the length of the refracted ray we will neglect actually. That's what directly we can take whenever light rays are incidenting convex lens, directly we can take as if they are converging. Okay children, fine. Now dear children, this converging action in a better way we can understand with the help of a prism and lens. Of course, before that what we will do is that, not before that, let us see once again. So same concept, dear children, we can understand with the help of actually prism. Children, in general, lens can be written like this. Lens is equal to prism plus glass slab. children, any lens can be written like this. So what is this equation? What is this formula here? Yes, so lens can be well understood with the help of concept of prism and a glass slab. Children, means what? Any lens can be assumed as if it is made up of with prisms and glass slabs. Means it's a combination of prism and what we can say glass slab also will give actually lens. Children, before going to discuss that what is the combination of a prism and a glass slab, let us recall once again what happens when light passes through a prism. Already we discussed it, children. Let us recall once again. So here is a prism. Children, it is a ABC. So here BC is the base of the prism. Children, whenever light incidents on the prism, okay, light ray will undergo refraction twice, and finally, dear children, light ray, that is emergent light ray, moves towards the base. Very, very important. Very, very, very important. Very, very important. So finally, the output light ray, that is the emergent light ray, will be coming towards the base of the prism only. This is the first point which we should import. And let us discuss about the glass slab. Let us think about the glass slab. So here is a glass slab. So here is light rays incident like this. Then it will undergo refraction. So this is what actually how we got, and we had discussed previously how refraction takes place when light ray passes through a glass slab. And children, this is the original path of the light ray, and shows that, so this will be the lateral displacement, right? It is a lateral displacement, and this is thickness. It is a thickness of the glass slab. Children, if thickness approaches 0, then lateral displacement also approaches 0. And already we discussed it, children, lateral displacement is proportional to thickness. When thickness of the glass slab is more, obviously lateral displacement is more. If the thickness of the glass slab is reduced, then what will happen? The lateral displacement also is reduced. Which means what, dear children, here, if the thickness is decreasing, this will be decreasing. Means the distance between original path of the light ray and the emergent ray gets decreased. Means if you can take a very, very thin glass slab, let us say, thin like this, very small glass slab which you have taken, very small. So it will be like this, and like this. So here now this decrease. If you can take a still very thin glass slab which you have taken, so then what will happen? Means here you cannot find the difference between emergent ray and incident ray. So that's what we can take very, very for a thin glass slab, region, we can take as if light ray is coming and passing like that. Means it appears as if light ray is undeviated when it passes through a glass slab. Children, so these 2 points are very important to understand even the converging action of lens also. That is, converging action of convex lens is understood with a combination of prisms and a glass slab also. So let us see that, dear children. So here convex lens is assumed to be made up of with prism and as well as glass slab. Look at here, dear children. So here is, so let us make here is middle part. It is a middle part. And here is one prism, okay, and here is one more prism, okay, fine. And children, don't forget that this is the base of the prism. Just I am highlighting, this is the base of the prism. So children, okay, here is principal axis. If a light ray is coming like this, here is a light ray coming. Children, as we know that whenever light ray is incidenting on a prism, the emergent ray should go towards the base of the prism. So base of the prism is this. So it goes base of the prism. Right? Fine. Now whereas here also it should go through the base of the prism only. Sorry, it should go towards the base of the prism. Means in both cases, here is the base of the prism. So emergent rays are going like this. So that they are getting converged. And children, this middle part is what is a glass slab. So, and very thin glass slab, children. Thin glass slab means thickness is almost 0. That much thin. Of course, in diagram we are showing like this, but it's a very, very thin. So, and already we discussed it, children. For lens, if any light ray is passing through its middle part, as middle part, it's like we can assume to be like very thin glass slab. So that what will happen? Light ray, though there will be a small lateral displacement, that is neglected. So this will take like this directly. So that's what we can say, this middle part is the optic center, this point. So that's what we can say that, so whenever light is passing through your optic center, it will go undeviated. The main reason behind it, why the light ray is going undeviated when it passes through the midpoint of the glass, what we can say, lens. So because of this reason only. So we should understand the concept of glass slab. Then this point will become very easy. Okay, children, fine. So these are the terms related to the convex lens and its nature. Now we will discuss what actually concave lens. Of course, we discuss concave lens in middle it is thin, and whereas at periphery it is very thick. It is when compared with the mid part, it is the thickness is more at the edges. Now let us discuss the terms related to the concave lens. So here is, so now look at here. Let us make here is concave lens. And children, as usual, the first refracting surface, second refracting surface. Now dear children, this second spherical surface is obviously it is a part of a sphere, and here also it is a part of a sphere. And dear children, so these spherical surfaces are a part of a glass hollow spheres. So let us take here is C2 and here is C1. So children, here this C1 and C2 only we can call it the center of curvatures. As like a convex lens, children, terms almost same only here, but the difference is that whether they are lying right side or left side is a matter here. So children, what is, let us recall, what is the center of curvature? So the center of a glass hollow sphere in which these curved surfaces are a part are called center of curvatures. And dear children, and here is a middle point is the optic center, and the geometric center of the any lens is called optic center. But scientifically, how can we discuss this, children? The point on the principal axis. Then where is the principal axis? Yes, so here is the infinite line, the infinite and imaginary line which is passing through center of curvatures and optic center is called principal axis. So dear children, now the point on the principal axis through which a light ray will go undeviated after refraction is called optic center. And children, here the distance between optic center and this center of curvature is called R2, and this we can take as a R1. We can take it as a R1. And children, as we discussed earlier, what is the difference between equiconcave lens, equiconvex lens? Children, if R1 is equal to R2, then we can call it as a equiconcave lens, whereas if R1 is not equal to R2, then we can call it as a biconcave lens. Biconcave lens. Children, here once again very important. All equiconcave lenses are biconcave, but whereas all biconcave lenses are not equiconcave lenses. So children, this what actually optic center, and here is a center of curvature. That is, it's a R1 and a R2. Now we will discuss the nature of the concave lens. Children, as we discussed for convex lens, what is the nature of the convex lens? It behaves like a converging lens. It shows converging action. But let us discuss even for concave lens also. So what is the action for this? So children, let us take a very thick convex lens so that we can understand easily the action shown by the concave lens. So here is, which already we discussed, here is a optic center. Dear children, here is air, here is a glass, again here is air. That is, it is rarer medium, here is a denser medium, again it is a rarer medium. Children, now let us take here a light ray is incidenting like this. Okay, let us take here somewhere else. So this is a light ray which is incidenting. But from where to where it is moving, dear children? It is moving from rarer to denser. Rarer to denser. Okay. And here, dear children, at this point, so here is a point A, and here you make a normal. Let us say N1 is a normal. Children, we know that when light ray moves from rarer to glass, what happens? It moves towards a normal. So it moves towards a normal. Fine. But again dear children, at this point, let us say point B, here it is trying to move from glass to air, that is denser to rarer. Again here you make one normal, you make a normal. So it goes away from the normal. Why? Denser to rarer, it speeds up, due to which it moves away from the normal. So this is how the final light ray is going to be. Now similarly dear children, here the light ray which is coming like this, okay na? So after refraction, how will take, okay, let us take some near to this, fine. Now it goes like this, and finally dear children, it gets emerges out like this. These two light rays dear children, they can never meet because as they are diverged, so extend back. So when these two light rays are extended back, so here they appear to meet in this case, dear children. So in the case of concave lens dear children, as the light rays are appearing meet, so it is said to be has virtual focus, that we will be discussing next. Okay, fine. So this is how means, so when light rays are incident on a concave lens dear children, after refraction the light rays are getting diverged. That's why dear children, concave lens is also called as diverging lens, is also called as diverging lens. Is also called as diverging lens. And dear children, as I said that, here let us say again same concept, T is the thickness. Our discussion is only for thin lenses. So here thickness tends to 0. So then we have very like very thin lenses, not this much also. So whenever light rays are meeting, whenever light rays are incidenting, especially parallel light rays are meeting dear children, what we will do directly, we will show diverging action, we will show. So they will be coming and beating at this point. Means as it is a very thick lens, so inside refraction is taking place. Of course here also will take place dear children. So as it is a thin lens dear children, the length of the refractor ray is neglected. Okay children, fine. And dear children, as we discuss convex lens with the help of what we can say combination of prism and a glass slab. Similarly dear children, here concave lens also assume it to be what we can made up of with prisms and a glass slabs. And look at here, and here is, this is how actually we can assume to be made up of with. And it should be the principal axis. And if any light rays are meeting like this, children don't forget that this is base of the prism and here is the base of the prism. As already we discussed that, so when light ray passes through a prism, after refraction it moves towards the base of the prism. So this is how it moves towards the base of the prism. Fine. And this middle part behaves like a very thin glass slab, very thin, just we discussed, very thin glass slab, so that what will happen, lateral displacement is neglected. Any light ray passing through optic center will go undeviated. But children, this discussion is only for thin lenses. So the light ray which is passing through the optic center will go undeviated. So these are the terms related to the convex lens and a concave lens and their nature. Children, convex lens is behaving like a converging lens, whereas concave lens is behaving like a diverging lens. Now we will discuss the very important thing is that, dear children, what is the first focal point, what is the second focal point, what is the first focal plane, and what is the second focal plane we will discuss. Children, look at here. So now, dear children, it is a optic center, directly we can draw. So the dear children, here is C1 and here is C2. So first we will be discussing first focal point or first focus, that is F1, very important. So how to define what is actually first focal point? Children, it is blindly you can say that point is going to be on the principal axis, no doubt about it. But why is that particular point is so special means, for example, here is a point, let us say F1 as I said that. So this is a point and a principal axis, dear children. For example, from that particular point, whatever the light rays are coming like this and incidenting on a convex lens, after refraction, dear children, after refraction, if they are going parallel to the principal axis, then that particular point on the principal axis is called first focal point. Let me repeat once again what actually first focal point of a convex lens. Children, it is a point on the principal axis from where the light rays are coming and incidenting on a convex lens. so that after refraction they will move parallel to the principal axis. That point on the principal axis we can call it as a first focal point. Then what is first focal plane? Did you look at here? Plane which is passing through the, this is first focal point, okay, which is passing through the first focal point and which is perpendicular to the principal axis. Children, a plane which is passing through the first focal point of the convex lens and which is perpendicular to the principal axis is called very important, first focal plane. So this is how we should understand. So children, this is a first focal point and here is a first focal plane. Now let us discuss about what is a second focal point, and similarly we will discuss a second focal plane also. So here is convex lens, here is a convex lens, okay, and here is its optic center, no doubt about it. So it should be the optic center, and here is C1 and here is C2, and here we got already F1 we got. Now what is the second focal plane, children? Second focal point here, children, if any light rays are coming parallel to the principal axis of convex lens, parallel like this, let us consider two light rays. After refraction they are going to meet a point, on the principal axis. This point only we can call it as a second focal point. Children, a parallel beam of light which is incidenting on a convex lens, after refraction they are going to meet at a common point on the principal axis. That point where all light rays are meeting after refraction is called second focal point, F2. Then what is second focal plane? Children, the plane which is passing through the focal point, that is second focal point. The plane which is, this is a plane, children, the plane which is passing through the second focal point and perpendicular to the principal axis is called second focal plane, Fine. And one more thing we need to understand here, the distance between first focal point and optic center is called first focal length, whereas the distance between optic center and second focal point is called second focal length. So it's very, very important. This is the first thing which we have to understand. And one more thing, dear children, here the distance between O to F1 and the distance between F1 to C1 is equal, which means what here? Radius of curvature is double than that of the focal length. That's what. Now onwards we are not going to use as a C to this one, as it is double than F2, directly we will write as a 2F1 only. 2F1. We can write as a 2F1. It is a very important. Whereas the children, here and here also similar thing here. When here distance between O and F2 is equal to the distance between F2 and C2. That is what here, the second radius of curvature is double than that of the second focal length. That's what. This we will read it as a, 2F2. This will read it as a 2F2 now onwards. So this is not F1, it is 2F1, and it's not a C1, it is 2F2. That's it. So these are the how can we define first focal point and the second focal point, first focal plane, second focal plane, first focal length and the second focal length. And one more thing, dear children, it's a very important thing is that if you can notice here, one important thing is that, dear children, after refraction, so before going to discuss that point, let us see, dear children, what is happening here. One important thing is that, dear children, here we have F1 and here it is going to be F2, okay, and here we have F2, means here we have two focus. But which one should we consider when we are dealing with the radii? Actually, it's a very important thing. So for any lens, dear children, the second focal the second focal point only is going to be considered as the focus, is going to consider the focus. So based on that point, children, for a convex lens, which side the focal point, that is a focus is lying, means you should tell right side only. Why? Because F2 is considered as a focus of that lens. So children, here F2 is going to be considered as a focus of that particular lens. So based on that, we can say that for a convex lens, dear children, focus will be lying always right side. And one more point you need to understand is that after refraction, at this point, so-called focus, light rays are meeting actually. So why we need to highlight this point? Because dear children, the focus, the point where light rays are meeting after refraction actually, then such a focus is called real focus. Such a focus is called real focus, and which gives real image. So convex lens is said to be has real focus. Why it is said to be has a real focus? Because after refraction, light rays are meeting. That's what we can call it. We can say that convex lens has real focus. Children, 2 points we need to understand. For a convex lens, focus, that is the focus is always lying right side, and it is a real focus. Okay, fine. For concave lens, so where the first focal point is going to be and where the second focal point is going to be located. Look at here. So children, let us draw here. Here is concave lens. Here is a concave lens such a way that here is optic center. So this side, okay, fine, let it be. So here is somewhere we got C2, and here somewhere we got actually C1. Now dear children, so for first concave lens, we will be discussing first focal point. First focal point. So what is the first focal point? What is the first focal plane? Also very important to understand. Children, here, if for example here, that you leave with this dot. If any light rays are coming and incidenting like this, they appear as if they are meeting. They appear as if they are meeting. Means actually they are not meeting. Children, try to understand. These are the two light rays which are coming and incidenting on a concave lens. And if there was no lens, they would meet this. Which means what? They appear as if they are going and meeting at this point. But after refraction, these two light rays in reality will go parallel to the principal axis. So the point where they are appearing to meet, is called actually first focal point. Children, it's very important to understand. So the light rays which are coming and incidenting on a concave lens, after they appear to meet at a common point in principal axis, but after refraction they are going parallel to the principal axis. That point where light rays appear to meet is called first focal point. And dear children, the plane which is passing through the first focal point, and perpendicular to the principal axis is called first focal plane. And dear children, so this is F1, and the distance between optic center and first focal point is called first focal length. And dear children, technically this first focal length is half of the radius of curvature of the lens actually. Means here we have studied that here this will be C2, right? Yes, this side C2 will be there. Means OC2 is double than that of OF1, or else children, the distance between O and F1 is equal to the F1 and C2. That's what children. So this is going to be termed as 2F1 now onwards. So 2F1 is a double than that of this F1. That's what we are going to call it as a 2F1. So children, this is what first focal point and first focal plane, very important. Now come back to the second focal point, and even we'll discuss second focal plane too. Now, so children, here is, let us make a bit small diagram. So here is similarly, so this side already we got, what we got here, f1 we got, and here we got 2f1, and this we got as a first focal length we got. And look at here, children, if any light rays, so here somewhere we already have C1. Okay, now let us take a parallel beam of light rays. Children, if parallel beam of light rays which are coming and incidenting here on concave lens, and we know that concave lens has diverging nature, means which diverges the light rays which are falling on it. So this light rays, dear children, what happens, you know, this light rays gets diverged like this, gets diverged. But dear children, diverged light rays can never meet. Then what we have to, let us extend this diverged light rays backward. Means we are extending the diverged light rays here. So this is a point where they are appearing to meet. So the point on the principal axis, dear children, where light rays are appearing to meet after refraction is called second focus. Is called second focus. Children, if parallel light rays are coming, the parallel light rays are coming and incidenting on a concave lens, and they are getting diverged, so they can never meet. So when they extend back, dear children, they are appearing to meet at a common point on a principal axis. This point only is called second focal point for a concave lens. And dear children, the plane which is passing, the plane which is passing through the second focal point of a concave lens and perpendicular to the principal axis is called second focal plane. Second focal plane, very important. It is called the second focal plane. And dear children, the distance between second focus, that is second focal point, to the optic center, is called second focal length. And dear children, so the distance between O and F2 is equal to the F2 and C1. Means what here? This radius of curvature is a double than that of the second focal length. That's what this point, now onwards, we are going to call it as a 2F2. is going to call as a 2F2. And dear children, as I told you that for any lens, second focal point is going to be considered as a focus. So now for concave lens, dear children, so which side a focus is lying? Can we say right side or left side? Just we have to find, we have to think about the second focal point. So it is the first focal point, it is the second focal point. Children, so this is a focus. So for concave lens, focus is always lying left side of the lens. So it's very important. For convex lens, that focus is lying on the right side, whereas for concave lens, focus is lying left side. And one more very important thing, dear children, here. What is that here? So this is the point where light rays are not meeting actually, they are appearing to meet. That's what this focus is called virtual focus. It's called as a virtual focus. So here convex lens has real focus, whereas concave lens has virtual focus. Now children, one more very important thing is that children, always we do not expect that the light rays are coming parallel to the principal axis only. Means it may not be a parallel incidence, sometimes it might be a oblique incidence also. Children, we know that, look at here, for convex lens, so for convex lens, we know that here is convex lens, is the principal axis O. So if any light rays are coming like this and incidenting, so after refraction, they will pass through the second focus. Children, now onwards we can call it as a focus, that's it. For convex lens, focus is always lying right side. Whereas for concave lens, let us see, if it is the same thing for a concave lens. So here is concave lens. So this is fine. So here is the optic center. So here is like this, if light rays are coming and incidenting on a concave lens, after refraction, they will get diverged. Yes, fine, they will get diverged and they appear to meet at a common point on a principal axis. Yes, this we can call the second focus. Rather, we can say simply the focus of concave lens is lying on a left side only. This is fine. But dear children, oblique incidence. So, where the light rays are meeting? Oblique incidence. Oblique incidence means what? Let me tell you. Oblique incidence. This is very, very important. Oblique incidence. Children, here is convex lens only and here is optic center. And we know that it is f2. Okay, fine. For a concave lens also, let us see here. For a concave lens also, this is going to be, and this side f2 will be lying, or you can write sometimes f also directly because it is a focus. Fine. Children, here these are the parallel light rays coming parallel to the principal axis. Now also dear children, we are going to take a parallel light rays only, but not parallel to the principal axis. Children, such a incidence means there will be some angle. There will be some angle. So, what is the difference between this beam of light and this beam of light? Children, both are parallel beam of light only. Both are parallel beam of light only. But what makes the difference? Here, these are the parallel light rays and parallel to the principal axis. But here, parallel light rays only, but not parallel to the principal axis. So, in such a case, where the light rays are going to meet is very important to understand. Children, here, we know that here is, children, look at here. This is focal point, right? Here is a focal plane. This is a focal plane. Addition, the light ray which is passing through the optic center, as we know that it will go undeviated. Okay, it is going undeviated. Fine, no problem with this light ray. And we know that convex lens is a converging lens. So the light ray gets converged like this. That's how it is going to happen. And this light rays are going to get converged. So here, where the light rays are meeting, dear children? Light rays are meeting at focal plane. Meeting at a focal plane. Okay, fine. Now come to this one, dear children. Here also, of course, then you can guess where the light rays are going to meet with this previous case. It is a focal plane. Here is a focal plane. So where they are meeting here? So they are meeting on focal plane only. So here is oblique incidence. So whenever parallel beam of light is coming and which is not parallel to the principal axis, then after refraction, where they will meet? In the case of convex lens, they will meet at a focal plane, but in the case of concave lens, they don't meet, they do not meet, rather they appear to meet. Why? Because convex lens has a real focus, concave lens has virtual focus. So children, these are the terms. Now the last topic in today's session is focal length. What is focal length? Means what are the factors on which focal length depends? Children, it's very, very important. Now children, so as I said that we are going to discuss about the factors on which focal length depends. So it is common for concave or convex. To understand it easily, we will take a convex lens, and same thing is applicable for even concave lens also. So now dear children, we are going to discuss factors on which focal length depends. So the first important thing is that medium in which a lens has been placed is very important. Dear children, whenever we are discussing about the focal length, means just we assume that the lens is placed in air only, and what is the focal length which we take when it is placed in air only. But let us see what happens when a lens is placed other than air. Let us take a water. What happens when lens is placed in a water, whether its focal length increases or decreases? Let us see, dear children. First, let us take a lens. It is placed in, let us say, dear children, is a case where lens is placed in air. Okay, so let us take a parallel beam of light. It's coming and incidenting. So here is after refraction. Fine. So it is the focus. So that this is going to be a focal length. So it is in the case of air. Same lens is placed in a water. Suppose same convex lens, children. Here is same convex lens, same identical, I am talking optic center. Now it is placed in a water. Now it is placed in a water. Now look at here, same this one. What happens? Look at here. So here is principal axis. Here is a principal axis. So look at here. Look at it. So like this they are going to meet, and this is going to be the focus, which means what here? It is a focal length. It is a focal length. Dear children, for sake of our convenience, just convenience, let us say it is f1 and is f2, let us say just f2. Okay, children, now it's a very clear that here f2 is greater than f1. f2 is greater than f1, which means what, dear children? When a lens is placed in a water, its focal length is increased. Its focal length is increasing. That is fun. But we need to understand why, when a lens is placed in a water, why its focal length is increasing. Children, for this we need to understand the relative refractive index. Children, here look at it. It is air whose refractive index is 1. It is a glass. Its refractive index is approximately 1.5. It's a water. Refractive index is 4/3. And again its refractive index is 3/2. That is relative refractive index. Children, in this case, the refractive index of glass with respect to air can be written as mu g by mu a, and this is going to be 1.5/1. So here refractive index of glass with respect to air is equal to 1.5, which we got. Okay, it is happy only. But now in this case, let us try to calculate the relative refractive index. That is what, children? Refractive index of glass with respect to water. So this is refractive index of glass by refractive index of water. This is for a glass, how much it is? It is 3/2 by it is 4/3. So the refractive index of glass with respect to water is going to be 9/8. Children, 9/8 is how much approximately here? 8 ones are 8. So again, so 1 will be there, 8 ones are 8 twos, some approximately we will get. Now children, look at here, the relative refractive index is decreasing. Relative refractive index is decreasing, very important, children. So here relative refractive index of glass with respect to, let us take glass with respect to water, is less than that of the relative refractive index of the glass with respect to air. So what you may get out. So what, sir? Children, in higher classes we will be learning about a lens makers formula. So according to that, for a given lens, dear children, the focal length is inversely proportional to the relative refractive index. Very important. Relative refractive index, very much important. So as relative refractive index increases, focal length decreases. Whereas relative refractive index decreases, then focal length increases. So children, that is the reason when a lens is placed in a water, its relative refractive index is decreasing. As relative refractive index is decreasing, dear children, its focal length is increasing. Children, it's very important point to understand. Here, when a lens, any lens, when it is placed in other than air, means other than a medium whose refractive index is more than that of the air, then what happens? Its relative refractive index decreases. So that what happens, dear children? The focal length increases. So hence we can say that in this case, we can say that when a lens is placed in a water, its focal length is increasing. Okay, children. So this is a very important point to understand. Okay, fine. And dear children, can we say that for a given lens, both focal lengths will be same always? Second one, dear children. Second point, very important point. Let us talk about the focal, this one. So if you can take, here is convex lens, here is optic center, this side it is f2 and here is f1, so that it is f1 and here is f2. So can we say that f1 and f2 are same? Always you can't say that. Always you cannot say that. The condition is that here r1 must be equal to r2, which means what, dear children? Focal length depends on the radius of curvature of that lens. And not only that, so if r1 is equal to r2, you can't say that f1 is equal to f2 always. No, it is a medium, dear children. It is a medium, very important. For example, dear children, here is air is there, this side, and here is water is there. Here water is there. Obviously, dear children, this focal length will be more than that of this focal length. But when these two focal lengths will be same, when both sides air and air, or both sides is water and water. If both sides is water, means both side medium also must be same. Medium also must be same. Then you can say that f1 is equal to f2. Then you can say that the focal length of that particular length. But in general, as whenever we are doing experiments with the lens, it is placed in air. So obviously both sides medium will be same. That's why generally we will take f1 is equal to f2. Generally we will be taking. Okay, fine. Now dear children, what happens if half portion of the lens, either concave or convex lens, is covered with a black color? Means completely that half part of the lens is not exposed to the light, let us say. So here third point, very important point it is. For suppose dear children, here is, let us say here is convex lens and here is its optic center. Children, like this light rays are coming. Let us say there are 3 light rays, and here also let us take few more light rays. So as we know that convex lens is a converging lens. Whenever parallel beam of light is coming incident on convex lens, after refraction they will converge at about a point. So let us say here is, so this is that point we discussed. Now the thing is that children, if so this is focal length, this is focal length. Now half of its part is not exposed to light, is covered with some black what we can say, some cover or a cloth, let us say, means either upper part or lower part. So let us take this part is a covered, children. For suppose this portion is covered the black color. So don't think that sir is saying that a black color but making red color, just for effective, that's it, to make it more effective, that's it. Then what will happen dear children? No more refraction through this part, right? No more refraction, no more refraction. But dear children, look at here, will there be any change in the focal length? Will there be any change in the focal length? No, there is no change in the focal length. But dear children, so it's a very important children. So if half of the part of the lens is covered with a black color, either it's a convex lens or concave lens, there won't be any change in the focal length. Before, if it is like 10 centimeters, now also 10 centimeters only. But what makes the difference? Children, before 6 light rays are meeting at this point, but now only 3 refracted light rays are meeting. Now you think dear children, so what makes the difference if 6 light rays are meeting and 3 light rays are meeting? So when 6 light rays are meeting dear children, the image whatever you are going to get will be more bright. Means when 3 light rays are meeting, obviously dear children, the brightness decreases. So here very important point what we have to understand is that, so when a lens, when half part of the lens is covered, then what happens, focal length is not changed, but whereas the brightness of the image whatever we are going to obtain decreases. So children, these are the factors on which actually a focal length of a convex lens or concave lens depends. Okay children, so in today's class just let us recall whatever we discussed. So we discussed only about the terms related. We discussed what is a convex lens, what is a concave lens, the types of convex lens and the types of concave lenses. The very important thing is that it's very important, what is that, to understand what is the first focal point, what is the second focal point. And finally we discussed about the factors on which focal length of a given lens depends. Okay children, in the next class we will be discussing the principal rays which are required to make a ray diagrams. Children, if you are perfect with that light rays, what are the light rays which we are going to consider in order to make a ray diagrams, then what will happen, you can play with the ray diagrams and even we can get the good command on the image formed and the characteristics of the image formed by the different lenses. Okay children, thank you so much, all the very best.